Alright, so we're going to look at solving and graphing compound inequalities, and if you notice I underline compound because that's the key word. Compound is when you put two things together. So there are two key words in mathematics that tell you to put things together, and those are and pen doesn't appear to be ready, and sometimes known as intersection, which is usually represented by this symbol, not the parentheses, it's just something to separate them. It looks like a giant N. That doesn't look right. Let me just use the symbol and erase these. Alright, so that's intersection. The other one is or. Or is sometimes known as union, which is represented by a large U. Okay, so you might see these in different forms of one another, and you might have been wondering why is intersection represented with this big N, and it's because it's the opposite of the union, which is represented with the U. So that makes a bit more sense. Alright, so let's look at some compound inequalities. If we had x is greater than 4 or x is less than 0, that would be represented like this on a number line. One circle would be located on 4. Actually, let's just graph this one. I'll even graph it in blue, and this one will graph in green. So on 4 on the number line, which is over here, let's put that there, that's 4. We'll actually have a open circle, and numbers that make this true are located to the right. Okay, so that's x is greater than 4. So all values that make this true are part of the solution set, or values that make this true, or both. There are no values that make both of these true, but there are values that make this one true, where x is less than 0. So if this is 0 on the number line, also gets an open circle, and we can graph it this way. So or is represented by values that make both statements true. You might want to think of hearing the word or means either. Alright, so if you see or, either one is true, then it's true. So these are the solutions of this compound inequality. So for instance, if I said, is 6 a solution to this inequality? You say yes, because it does satisfy this one or that one. It might only solve this one, which it does, it's over here, that's 6, but it is a solution to this compound inequality. Alright, so let's take a look at a AND inequality. This would be an AND inequality. Let's say we have x is greater than or equal to 3. Matter of fact, let's change that around. Let's say 3 is less than or equal to x, and x is less than 6. Alright, so again, we'll do this one in blue and this one in green, just to make this a little easier to follow. Here's our number line. Alright, so or means either, and means both. Now or in math is actually, it means, in mathematics, doesn't mean exclusive or, meaning you can only be one or the other. It means as long as it's in one. That's the union, what puts them together. Alright, so and. The blue one here, it says values that are that make this true. So our circle would go on 3. So that's 3. It'd be a closed circle, because it is equal in this case. Values that make 3 less than x would be values that are located in this direction. Alright, and this one, x is less than 6. We'd start with our circle on 6, and it's open. And values that make this true are values over this way. But where are the values that make this and this true? That's this overlapping area here. So these values over here, whoop, that was too big of an eraser. These values over here don't make, these values over, I don't know why it's erasing the entire line when I do that, but that's not going to work for me. The only values that make both of these true is this middle area. Alright, so this would be the solution set of that inequality. Alright, let's see if I can erase. It's a little better. So yeah, these, while they do add, well, those extended parts here, those extensions do solve individually. These are the only numbers that answer both. So if I want to find a number that makes this true and this true, I would look here. So an example of a number like that would be 4, right? Does 4 make this true? Yeah. 3 is less than 4, and 4 is less than 6. Alright? Sometimes an AND inequality is actually represented like this. Without the word AND, they can be overlapped. Let me move that. Whoops, I want to get the whole thing. For some reason I can't get this. I see why I can't get it, since I wrote it as like one sentence. So let's write it again. That's x is less than 6. Okay, so sometimes they're written like this. That's the same thing as saying 3 is less than x and x is less than 6. Alright, so I'm going to show you an example of each of these. They'll be on your worksheet, so you can actually look up those examples. Alright, so here's the first one. This is an OR inequality. So first we have to solve them both. So I'll solve the first one in green and the second one in purple. So we'll add 3 to both sides, and we'll get 2x is less than 14. Divide both sides by, let's actually do 2x. I like the steps I'm using, but I don't like to double the colors. I want to make sure everything is clear. So add 3 to both sides, and that'll leave over 2x is less than 14. Divide both sides by 2. And since we're dividing by a positive value, we will not be reversing the inequality, so that'll leave us with x is less than 7. Alright. This is OR, so we're going to be using both, so we can actually just graph this immediately. Alright. Open circle on 7. Values that make that true are located in this direction. Alright. And what else? The other one. Okay, so that one I said I'd do in purple, so we'll do that in purple. For this one, we'll add 10 to both sides, and that will give us negative 8x is less than negative 72. We'll divide both sides by negative 8. When we do that, we are dividing by a negative, so the golden rule of inequality says we have to reverse the direction of the inequality. Negative 72 divided by negative 8 is positive 9. So let's graph that. It's an open circle here. Numbers that make that true are located here. So our solution set goes from negative infinity up to 7, and then starts again at 9 up to, but not including 9, and up to infinity. If you wanted to represent that using interval notation, it would look like this. Because again, this is this or that. So in interval notation, it would say starting at negative infinity up to 7, parentheses mean not including. Now we can't include negative infinity because it's not a number. Or I guess I should put that in blue. Or, and in purple here, that would be 9 up to positive infinity. Alright, let's take a look at another example. This is an AND inequality. This we will, same thing, this one in green, that one in purple. So we'll add 10 to both sides, and that will leave us with Negative 2v is less than 16. We have to divide both sides by negative 2. And v will be greater than, again, we divided by negative, we have to reverse the symbol, greater than negative 8. This side will do the same. Since this is and, we kind of want to see where our overlapping area is before we actually graph it. So actually start doing this in blue so we can finish in purple. Take away 12 from both sides. Alright, this will get 6v is less than negative 18. Divide both sides by 6. And that will leave us with v is less than negative 3. Alright, so it has to be two things. It has to accomplish two things. First, we're looking for values of v that we want v to be greater than negative 8, meaning this way, and we want v to also be less than negative 3. So, whoops, purple, which would be located this way. So the overlapping area is this middle section here, right in between them. So this would be our graph of v is greater than 8 and v is less than negative 3. And just looking at that graph, that can also be written as negative 8 is less than v, which is less than negative 3. So that's this. Alright, let's take a look at another example. Last one. This one is actually... Alright, whoops, that came out of nowhere. Alright, here's what we're going to do. Because these share the same center, these can be written as two different inequalities. That would be 1. And this would be another. So that would be negative 12b minus 14 is less than or equal to 14 minus 5b. Alright, so that's normally how you would deal with these triple inequalities. Alright, so this is still an and inequality. It has to be both. Alright, anything that looks like this is an and inequality. So let's solve those. Here, I don't even want to have to use the golden rule. So to do that, I'm going to make sure my b value is positive before I move on. Alright, so that's going to be 16b plus 18. That's a 6. It's really poorly written. Is less than or equal to negative 14. Add, subtract 18 from both sides. You get 16b. 16b is less than or equal to negative 32, which means b is less than or equal to negative 2. And over here, purposely again, I'm going to make b positive, so I'm going to add the 12b to both sides. That way this side will be positive. That way I won't have to deal with the golden rule. I think that's how I dealt with it when I went to school. Because I totally forgot this rule when I started teaching. It just didn't register that it needed to be done, because I just never set myself up that way. I knew it always gave me a problem. I didn't remember why. So I just always did this. That's 7b. Now we'll subtract 14 from both sides. Alright, and that'll leave us with negative 28 is less than or equal to 7b. So b must be greater than or equal to negative 4. And you'll notice I even say it in reverse. So I could say this: b is greater than negative 4, or negative 4 is less than b. It means the same thing. Alright, so now to graph this. The red one, we'll start here on negative, that's 6, 4, 2, and it's equal to, so solid. Numbers that are less than negative 2 are located this way, and the green one is numbers where b is greater than -4, which is here. So this is our solution set.